the possible values of alpha. We have to find the value of alpha. We have to find the value of alpha, for which the variational problem integration 0 to 1 3y square plus 2x cube plus into y dash dx. It is given that this is the boundary condition y alpha is equal to 1 has extremals are -1 0 0 1 -1 1 -1 0 1. So basically we have to find the value of alpha for the following functional. It is given that it has extremal, that is the solution satisfy the boundary conditions. Okay, so here f is equal to, what is f? Here f is this, right? So here f is equal to, here f is equal to 3y square plus 2x cube y dash plus 2x cube y dash. So this is f. Euler's equation is del f del y minus ddx of del f del y dash is equal to 0. So this is the Euler's equation, del f del y minus ddx of del f del y dash is equal to 0. So this is Euler's equation. So this implies that del f del y. So what is del f del y? Del f del y. So this is 6y, right? Del f del y dashed, del f del y dashed. So this is 0. That means 2x cube. Okay. So del f del y is 6y minus ddx of del f del y dash, that is 2x cube, is equal to 0. So this implies 6y. So derivative of x cube, that is 3x squared. So 6x squared is equal to 0. That means x squared is equal to y. Y is equal to x squared. So this is the solution. Now it has extremal, that means it satisfies the boundary condition, right? A functional will be extremal if the solution satisfy the boundary conditions. So here it has extremal, that means this solution must satisfy these boundary conditions. So what is the boundary conditions here? Here y alpha is equal to 1, right? Y alpha is equal to 1. That means when x is equal to alpha, y is 1. When x is equal to alpha, so alpha square, y is 1. Getting my point? Y alpha is equal to 1. That means when x is equal to alpha, y is 1. X is equal to alpha, that is alpha square, y is 1. So alpha square is equal to 1. That means alpha is equal to plus 1 or minus 1. So which option is correct? The values of alpha will be plus 1 or minus 1. That means option C is the correct answer. Okay.